Hi friends, welcome back to another maths class. Today we are discussing some problems related to matrices. Okay, the first problem, construct a 3 by 4 matrix A is equal to Aij whose elements are given by Aij is equal to half into mod I minus 3j. Okay, so we have to construct a 3 by 4 matrix. A 3 by 4 matrix. So A is equal to A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34. So 3 by 4 matrix. 3 by 4. 3 rows and what? 4 columns. So we have to find all these elements A11, A12, all these elements we have to find. We have to find what? A11 first. See what is A11? A11 is equal to half into mod, see I minus 3j, I become what? 1 minus j also become what? 1. So 3 into what? 1. That's equal to half into, see 3 into 1 is 3, 1 minus 3 is what? Minus 2. So mod is there, it become what? 2. So that's equal to 1. So A11 is 1. Similarly, what is A12? Half into mod 1 minus 3 into 2. That's equal to what? Half into 3 2s are 6. 1 minus 6 is what? 5. So mod is there. So what? 5 by 2. A13. What is A13? Half into 1 minus 3 into 3. That is equal to what? Half into 3 3s are 9. 1 minus 9 is what? Minus 8. Mod is there. So what? It is what? 4. Now A14. What is A14? Half into mod 1 minus 3 into 4, that is equal to half into 3 4s are 12, 1 minus 12 is minus 11, mod minus 11 become what? 11, that's equal to what? 11 by 2. Now A21, so what is A21? Half into mod, here I is 2, so 2 minus 3 into 1, that's equal to half into 3 1s are 3, 2 minus 3 is what? 1. So that's equal to what? Half. A22. What is A22? Half into 2 minus what? 3 into 2. That is equal to half into 3 2s are 6. 2 minus 6 is what? 4. That's equal to what? 2. Now A23. What is A23? Half into mod 2 minus 3 into what? 3. That is half into 3 3s are 9. 9 minus 2 is what? 7 is equal to what? So 7 by 2. Now A24. What is A24? Half into mod 2 minus 3 into 4. That's equal to what? 3 4s are 12. 2 minus 12 is what? 10. So half into 10 is equal to what? 5. Now we have to find what? A31. So what is A31? A31 is equal to half into what? 3 minus, I become what? 3. 3 minus what? 3 into 1. That's equal to half into 3 1s are what? 3. 3 minus 3 what? 0. So answer is what? 0. Now A32. What is A32? Half into mod 3 minus 3 into 2. That's equal to half into 3 2s are 6. 3 minus 6 is what? 3. So into 3. That's equal to what? 3 by 2. Now A33, that's equal to what? Half into 3 minus 3 into 3, that's equal to what? Half into 3 3s are 9. 3 minus 9 is what? 6. So that's equal to what? 3. Now A24, the last element is equal to what? Half into 3 minus what? 3 into 4. That's equal to what? Half into 3 4s are 12. 3 minus 12 is what? 9. So it is what? 9 by 2. So we got all the elements. So the matrix A is equal to matrix what? First is A11. A11 is what? 1. Then what is A12? It is what? 5 by 2. Then it is what? 4. Then it is what? 11 by 2. What is A21? A21 is what? Half. Then it is what? 2. Then it is what? 7 by 2. Then it is what? 5. A31 is what? 0. A32 is what? 3 by 2. A23 is what? it is 3 and is what? 9 by 2. So this is what the required matrix. Okay. Now the second problem, if f of x is equal to matrix cos x minus sin x 0, sin x cos x 0, 0, 0, 1, then show that f of x into f of y is equal to f of x plus y. Okay, we have to prove that f of x into f of y is equal to what? F of x plus y. So given that f of x is equal to what? A matrix, we have to find what? F of x into f of y. See, f of x into f of y is equal to. So what is f of x? It is given. F of x is cos x minus sin x 0, sin x cos x 0, 0, 0, 1. This is what? F of x. So what is f of y? See, f of x is what? X, a function of x. So what is f of y? It is a function of y. So f of y become cos y, and what? Minus sin y, 0, sin y, cos y, 0, 0, 0, 1. Okay, so this is f of x into what? F of y. Now we have to what? Multiply this. Okay, we have to multiply. So first row multiply with the first column. So cos x into cos y, that is what? Cos x cos y, plus minus sin x into sin y, that is minus sin x sin y. Then what? 0 into 0 become 0. Now multiply first row with what? Second column. So cos x into minus sin y, minus cos x sin y. Then minus sin x into cos y become what? Minus sin x cos y. Then 0 into 0 become what? 0. Now the first row multiply with the third column. Cos x into 0 becomes 0. Minus sin x into 0 becomes 0. 0 into 1 also becomes 0. So it is what? 0 only. Okay. Now we multiply second row with the first column. Sin x into cos y, that is sin x cos y. Then what? Plus cos x into sin y, that is cos x sin y. Then 0 into 0 become what? 0. Now second row with the what? Second column. Sin x into minus sin y become what? Minus sin x sin y. Then cos x into cos y plus cos x into what? Cos y, plus 0 into 0 become what? 0. Now second row with the what? Third column. Cos sin x into 0, 0. Cos x into 0, 0. 0 into 1 also 0. All 0 only. Now the third row with the what? First column. 0 into cos y, 0. 0 into sin y, 0. 1 into 0. So the element is what? 0. Now 0 into sin y, 0. 0 into cos y, 0. 1 into 0 also what? 0. Now 0 into 0 becomes 0. Plus 0 into 0. 1 into 1 is only what? 1. So this is the answer. That's equal to. See, cos x cos y minus sin x sin y. The last year we learned trigonometry. We learned what is cos x cos y minus sin x sin y. It is what? Cos x plus y. Cos x cos y minus sin x sin y is what? Cos x plus y. Now here now minus sign is here. Here also what? Minus sign. So we can take what? Minus is out, common term. Minus is common. It becomes what? Cos x sin y plus sin x cos y. Okay. Cos x sin y plus sin x cos y. That's equal to what? Sin x plus y. Sin x plus y. And third element is what? 0. Here sin x cos y plus cos x sin y. What is sin x cos y plus cos x sin y? It is also what? Sin x plus y. Here see minus sin x sin y plus cos x cos y. That means what? Cos x cos y minus sin x sin y. That's equal to what? Cos x plus y. Then last element is what? 0. Here is what? 0, 0, 1. Okay, the answer we got. Now just compare this matrix the question. See, cos x, here what? Cos x plus y. Instead of x it is x plus y. Here sin x, here what? Sin x plus y. Then 0. Sin x become what? Sin x plus y. cos x become what? Cos x plus y. So this is a function of x plus y. The function of x plus y, that is what? F of x plus y. So we got what? F of x into f of y is equal to what? F of x plus y. That is the proof of this question. The third question. See, if A is equal to matrix 0 minus tan alpha by 2, tan alpha by 2 0, and I is an identity matrix of order 2, then show that I plus A is equal to I minus A into matrix cos alpha minus sin alpha cos alpha. Okay. In this problem, we make a substitution. See, let this tan alpha by 2 is equal to a variable t. Okay, to avoid the confusion, it's better. Tan alpha by 2 is equal to t. Then, if tan alpha by 2 is t, so what is cos alpha? We know that cos alpha is equal to 1 minus tan square alpha by 2 by what? 1 plus tan square alpha by 2. We learned last year cos 2 alpha is equal to 1 minus tan square alpha by 1 plus tan square alpha. So what is cos alpha? 1 minus tan square alpha by 2 by 1 plus tan square alpha by 2. That's equal to 1 minus t square by what? 1 plus t square. Okay. Now what is sin alpha? Sin alpha is equal to, the formula what is sin 2 alpha? Sin 2 alpha is equal to 2 tan alpha by 1 plus tan square alpha. So sin alpha is equal to 2 tan alpha by 2 by what? 1 plus tan square alpha by 2. That is equal to 2t divided by 1 plus t square. Okay. So let tan alpha by 2 is equal to what? T. Then what? Cos alpha become 1 minus t square by 1 plus t square, and sin alpha is what? 2t by 1 plus t square. Now, what do you have to prove? 1 plus I plus A. See the LHS part. The LHS part is what? I plus A. What is I plus A? I is equal to what? Is a matrix 1, 0, 0, 1 plus A. What is A? The matrix A becomes, see, 0 and minus tan alpha by 2, 0. Tan alpha by 2 is equal to what? T, no? So it becomes what? Minus T, and what? Tan alpha by 2 becomes T and what? 0. Okay. So that's equal to 1 plus 0 is what? 1. 0 plus minus T becomes what? Minus T. And 0 plus T is what? T. And 1 plus 0 is what? 1. So this is what? The LHS part. Okay. Now RHS. See, RHS is equal to, see what is RHS? I minus A. So what is I minus A? See, I plus A here. So what is I minus A? 1 minus 0 is what? 1. 0 minus T become what? T. 0 minus T is equal to what? Minus T. And 1 minus 0 is what? 1. So this is I minus A into, see, I minus A into cos alpha. What is cos alpha? We know that cos alpha is equal to 1 minus t square by 1 plus t square. Then minus sin alpha. What is minus sin alpha? Minus 2t by 1 plus t square. Sin alpha, that is 2t by 1 plus t square. And what? Cos alpha, that is 1 minus t square by 1 plus t square. Okay. Now we have to multiply. The first row multiply the first column. So 1 into 1 minus t square by 1 plus t square plus t into this. 2 into 2t become what? 2t square by 1 plus t square. Now first row with the second column. 1 into this become what? Minus 2t by 1 plus t square plus t into 1 become t minus t into t square become what? T cube divided by what? 1 plus t square. Now second row with the first column. Minus t into this become what? Minus t plus t cube divided by what? 1 plus t square. plus 2t divided by 1 plus t square. Now second row is second column. So minus 2t into minus t into minus 2t become what? 2t square. Then 1 into this become what? Plus 1. 2t square by 1 plus t square, and 1 into this 1 minus t square by what? 1 plus t square. Okay. This is the product. Now that's equal to, we can simplify this. 1 minus t square plus 2t square. See, denominator is common, same denominator, so we can add numerator. 1 is there, 1 minus t square plus 2t square become what? T square. So 1 plus t square by 1 plus t square. Here minus 2t plus t become what? Minus t, then what? Minus t cube divided by what? 1 plus t square. Here minus t plus 2t become what? T plus what? T cube divided by 1 plus t square. Here 2t square and what? Minus t square. What is 2t square minus t square? T square. Again 1 is there. So 1 plus t square by what? 1 plus t square. So that's equal to. See, 1 plus t square by 1 plus t square become what? 1. Here minus t we can take out. Okay. Here minus t and minus t cube can take minus t out. So minus t we can take out. Minus t into what? 1 plus t square by 1 plus t square. Here again see t plus t cube. From t plus t cube you can take t out. T into 1 plus t square by what? 1 plus t square. Here same 1 plus t square by 1 plus t square become what? 1. So this equal to matrix 1. This get cancelled. Answer is what? Minus t is remaining. Here also cancel. T is remaining and what? 1. So we got what? RHS is equal to matrix 1 minus t t1. So what is LHS? 1 minus t t1. Both are same now. LHS equal to RHS is equal to what? LHS. Hence what? The proof. Okay. It's a very important problem. Practice it. Now question number 4. Using elementary transformations, find the inverse of each of the matrices if it exists. The first one, matrix 1, 3, 2, 7. So we have to find the inverse of this matrix by what? Elementary transformations or elementary operations. We have to apply elementary transformations or what? Elementary operations. We have to what? Find the inverse of this matrix. We suppose now the given matrix is suppose A. Okay, we take what? The given matrix is A. Now to find the inverse, we write now A is equal to IA. I already explained this. To find the inverse, we can either apply elementary row operations or what? Elementary column operation. Now I am using what? Elementary row operation. So when we are using elementary row transformations, write A is equal to IA. So what is A? Is I. That is A is equal to what? 1, 3, 2, 7. That is equal to I. What is I? I is what? 1, 0, 0, 1 and what? A. This A we can write what? A. Okay. Now A is equal to I. Now we apply a sequence of elementary row operations. We can apply 1, 2, 3 many operations. Our aim is now, our aim is to make this matrix what? I. To make this matrix I. So this matrix become what? A new matrix. Okay, B. That matrix will be what? The inverse. So we have to make this matrix into what? I. How can we make this into what? I? By operations. So here 1 now, we need what? 1. Because 1 is here, 1 we need. This element we have to change into what? 0. So how can we make this element 0? So we are applying the operation R2 changes. Okay. We are changing the second row. Second row we are changing. R2 changes. R2 minus 2R1. Applying the operation R2 changes R2 minus 2R1. This become what? 1, 3, no change. First row is not changing. The second row, see, 2 minus R2 minus 2R1. So 2 minus 2 into 1 become what? 0. 7 minus 2 into 3. What is 7 minus 2 into 3? 2 3s are 6. 7 minus 6 is what? 1. That is equal to, here also, when we are applying an operation on left side, we have to apply on what? Right side also. Here 1 will not change, 0 also will not change. Here see, R2 minus 2 R1. 0 minus 2 into 1 become what? Minus 2. 1 minus 2 into 0 become what? 1 only. Okay. This A will be A only. Okay. See, now here 1 is here, 0 is here, 1 is here. In an identity matrix, first element is 1 is okay. This element is what? 0, that's also okay. This also 1 is also okay. Now what? We have to make this 0. This 3 we have to make what? 0. For changing this 3 to 0, that is, we are changing what? R1. R1 changes R1 minus 3R2. See, we are applying the operation. R1 changes R1 minus 3R2. So this becomes, see, 1 minus 3 into 0 is what? 1 only. 3, R1 is 3 now. 3 minus 1 into 3 become what? 0. Okay, here 0 and here what? 1. So the same operation will apply here also. See, R1 minus 3R2. So 1 minus 3 into minus 2. So 1 minus 6. 1 minus 6 become what? 7. 0 minus 3 into 1. 0 minus 3 is what? Minus 3. Here what? Minus 2. Here 1. And what? A. Now we got here I. See, this is like what? I is equal to, this is a new matrix B into A. So if I is equal to what? BA, we know that B is what? The inverse of A. B is the inverse. So A inverse, we can write what? A inverse is equal to, we can write what? A inverse is equal to what? Matrix 7 minus 3, 7 minus 3, minus 2, 1. Minus 2, 1. Okay. Here second one, matrix 2 minus 6, 1 minus 2. Okay, we have to find inverse of this matrix. So as before, write what? A is equal to what? IA. Write A is equal to IA. This is a matrix A. Write what? Matrix 2 minus 6, 1 minus 2 is equal to I. What is I? 1, 0, 0, 1 into what? A. Okay. Now we apply some operations and we have to what? Make this into what? I. See, the first element is what? 2. 2. But actually we need what? We need 1. Here 1 is there now. So we interchange this. Okay. The first operation is R1 interchange R2. Okay. We are interchanging R1 and R2. Interchanging R1 and R2. So the matrix become what? 1 minus 2, 2 minus 6. Okay. That is equal to, here also what? Interchange 0, 1, 1, 0 into what? A. Okay. Now you got here what? Now this element we have to what? Change into 0. Okay. This element will change into 0. So what the operation will change now? We are changing R2. R2 changes R2 minus 2R1. Okay. R2 changes R2 minus 2R1. So this become what? First row will not change, 1 and minus 2. See, R2 minus 2R1. 2 minus 2 into 1 becomes 0. See here, what is here? Here it is minus 6 now. So minus 6 minus 2 into minus 2 become what? Minus 2. That is equal to, here 0, 1. 1 minus 2 into 0 become 1. 0 minus 2 into 1 is what? Minus 2 into what? A. Okay. See, here 1, here 0. Now, we have to make this into what? 1. Okay. This minus 2 into what? Make into 1. For that, R2 changes minus 1 by 2 R2. Multiply the second row with what? Minus half. Here minus half is the minus 1, minus 2 is there now. So multiply with the minus half. It becomes what? See, 1 minus 2, 0. Minus 2 into minus half become what? 1 is equal to 0, 1. 1 into half become what? Minus half. Here what? It is 1. Okay. Now it is 1 is here, 0 is here, 1 is here. Now this 2 we have to what? Make into 0. For that R1 changes R1 plus 2R2. Okay, R1 changes R1 plus 2R2. That implies here 1, no change. Minus 2 plus 2 into 1 become what? 0. Here what? 0 and here what? 1. This equal to, okay, what will come now? 0 plus what? 2 into minus 1. So what is 2 into minus half? It become what? Minus 1. When you add here, minus 1. So 1 plus 2 into 1 become what? 3. Here what? Minus half, and here it is 1. See, this is what? I is equal to, here all A is there. So I is equal to what? B into A. So this is the answer. That means A inverse is equal to this answer. Minus 1, 3, minus 1 by 2 and what? 1. Okay, this is the inverse of the matrix. Minus 1, 3, minus half, 1. Okay. Now the third question. See, matrix 6, minus 3, minus 2, 1. Okay, we have to find the inverse. So as before, we write what? A is equal to what? IA. A is equal to IA. This is a matrix A, no? So matrix 6 minus 3 minus 2 1 is equal to, what is I? 1 0 0 1 into A. Okay. Now we have to make this into what? I. Okay. The first element is what? 6 now. This 6 we have to change into what? 1. So what will do now? R1 changes 1 by 6 R1. Multiply the first row with what? 1 by 6. Multiply the first row with 1 by 6. That implies, see, 1 by 6 into 6 become what? 1. 1 by 6 into minus 3 is equal to what? Minus 3 by 2. Minus 1 by 2. And what? The second row is what? Minus 2 and what? 1, no change. That's equal to, here 1 by 6 into 1 become 1 by 6 into 0 become what? 0, 0 and what? 1. Okay. Okay. So we got what? Here 1. Okay. Now this element we have to change into what? 0. For changing this 0, we are changing R2. R2 changes R2 plus 2R1. R2 changes R2 plus 2R1. See, here 1 minus 1 by 2, no change. Now R2 plus 2R1 minus 2 plus 2 into 1. Minus 2 plus 2 become what? 0. Here 1 plus 2 into minus half. So 1 plus 2 into minus half again become what? 0 is equal to, here what? 1 by 6 and what? 0. So R2 plus 2R1. 0 plus 2 into 1 by 6 become what? 1 by 3. Here what? 1 plus this become what? 1 only. So what? Here, note that two elements of a row are what? 0. So I already explained that after applying one or two operations, if all the elements of what? The matrix A are 0, that means what? No, this matrix does not exist inverse. Okay. After applying 1 or 2, 3 elementary operations, if all the elements of a row is coming 0, that means we can't find the inverse. So means what? Inverse does not exist. Inverse does not exist. Okay, we can stop here, right? What? Inverse does not exist.